Okay, welcome everybody to Go in 5 Minutes, episode 16. Today we're going to talk about the new subtest feature in Go 1.7's testing package. So you can go check out all the gory details at godoc.org/testing. That one is a tongue twister. Before we get started, I want to take a little bit of extra time today to call out some super exciting new developments that I really couldn't be happier to announce. First of all, we've got our first sponsor for the screencast series. That is Minio. I'm going to call out a lot more about Minio and how they're involved a little bit later in the screencast. But for now, if you don't do anything else, just go check them out at https://minio.io. Second of all, we're live on Twitter. I'm mainly using Twitter now to, of course, notify about new screencasts and blog posts. I'll get to the blog in a second. But I'm also trying to tweet out some new announcements to keep everyone up to date on the Go community. So definitely go follow us there, twitter.com/goin5minutes. And third and finally, I mentioned it already, the new blog is up. We've got a blog at goin5minutes.com/blog. Definitely go check out all the articles there. I'm going to be writing a lot of the same types of content as you see in the screencasts, but in tons more detail. And of course, go subscribe to the newsletter, goin5minutes.com/subscribe. And just as I tweet out notifications of new screencasts and blog posts, I'll also be sending them via email. All right, so let's get to some real code. What are subtests? So first of all, subtests are a very simple way to add on to your existing tests the ability to run tests inside of the tests that you already have. So these are tests that are, of course, subtests to what you already have. So you're executing them in a function closure inside of the tests that you're already running. So you can inherit essentially all of the variables that you already have, all of the setup, all the data structures, and so on and so forth. But they run and they are reported as a completely separate test. So as I mentioned already, it's really useful for having setup and teardown logic. And those are per test setup and teardown logic. So this is much more fine-grained than just a test main, which is the setup and teardown logic for your entire test suite. We're also going to talk a little bit about how to do table-driven tests with these subtests. It's a really clean and efficient way, and also a great way to do reporting for your table-driven tests. And we're even going to talk about how to parallelize your table-driven tests using subtests. So let's get into some example code. First of all, the thing we're going to test something that we've written here called a set. Now a set is exactly what you think it is. It's just elements that can be accessed and removed and added to this data structure in constant time. So we're implementing a set as just a map with the set element as the key and nothing in the value. So that allows us to do that constant time access and removal and so on and so forth. So here are the four main functions we're going to test. We're going to test the function that can see whether an element exists, that function that can add an element, function that removes an element, and then of course a function that cleans up the entire set and makes it empty again. So let's look at our first test. This is just going to be called test basic. So in this test, as you can kind of see here, we're adding 10 elements to the set. This is our setup logic. We've got teardown logic here, which is remove all. That just makes the set empty again. And then we go through each element and make sure that the element that we expect for that loop iteration actually exists in the test. Now here's the special part, t.run. So you pass a test name to t.run, and our test name is just an element with a number, a loop iteration in the string. And then we pass it that function closure I mentioned. So this function closure looks exactly like the function up here. It's just running with the context of the entire test suite, the entire test function already in it. So of course you can see we're inheriting the set that we created here on line 12. And we're inheriting that expected element that we created on line 19. So here we're just making sure that the element that we added above on line 15 actually is reported that it exists inside of the test. So before we go on to the next two tests that I want to show off, I wanted to talk a little bit more about Minio. Minio is an object storage server designed to be very minimal and scalable. It enables app developers to build their own Amazon S3 compatible cloud storage without any other special storage skills. And I especially love Minio because they're huge contributors to the Go community. And of course, they're really a great group of people too. So I really, really encourage you to go check them out at minio.io. They're also on GitHub, github.com/Minio, and they're on Gitter. Go check out gitter.im/Minio/Minio. You can ask questions or you can just hang out with them. Like I said, they're a great group of people to just talk to about everything Go or everything storage or so on and so forth. So let's get back to those other two tests. So here I want to show off an example of a table-driven test. So just like before when we did a bunch of adds to the set, here we're going to create a bunch of elements that we intend to add later to the set. So this is the table in table-driven tests. Now here, of course, this is the setup logic that we're going to do. This is just creating the new set. And then down here, we're going to call t.run for each element in the table that we created above here on lines 16 to 23. So same format here. We pass a string, this is the name of the subtest, and then we pass the function closure, and this is the actual logic that we want to run for the test. So then down here, fairly simple test. We're making sure that it doesn't exist, the element doesn't exist already in the set. Now we're making sure we can add it to the set. Now we're making sure it actually does get reported as existing in the set. And then here we're removing it and making sure that it gets reported as removed from the set. And finally, I want to show off a concurrent table-driven test. Now, this is almost the exact same code as I just showed, with one exception here. We're running that t.run function inside of a Go routine. Everything else is exactly the same. So I want you to keep that in mind because this is going to make us access the set concurrently. And if I go back to the set here, you can see it's documented and true that none of the functions on the set are concurrency safe. The second thing I want you to keep in mind is that there's a build tag on this. Now if you're not familiar with build tags, essentially what this means is if the test is not run with this build tag turned on, and I'll show you how to turn that on in a second. If the test is not run with this build tag turned on, none of this code will execute at all. It's like this file doesn't even exist. So let's head over to our make file, and let's first run the test, just a simple test make target. You can see we're running it with verbosity turned on. So here we go. And there you have it. So you can see we've got our big test called test basic, and here are all the subtests, all 10 of the subtests. They all passed, that's great. And then you can see our test table driven, our big test there. And here are all of the elements in the table driven test. There's all 6 of them, and they all passed. But once again, notice that if we go back to our table driven concurrent test, this and all of its subtests don't show up. And that is because we didn't have the tag turned on. And this is how you turn on the tag. So let's run this make target, make test race condition. And there you have a failure. And this is what we expected. We have a failure that's generated by the race detector. Now before I go into the failure, this is how you turn on the race detector. Now this makes your tests compile and run a little bit more slowly, but it can be a super useful tool, especially when you're running concurrent table-driven tests, as we are. Now the race detector reported a data race, and I'll leave it as an exercise to you to go and fix the data race. And here's a hint, you'll want to fix the data race in here, most likely using a mutex or a read-write mutex. And as you go and fix it, you'll see that these data races will start going away. So this data race will go away, and then the next data race will pop up, and as you fix that, it will go on so on and so forth until finally all the tests pass. So that's all for today. I really encourage you to go check out your own unit test suites and just play around with this. You don't have to completely opt in to subtests. As you can see here, you can very easily write another test table driven function that doesn't use t.run, and there's no harm, no foul. Also something very useful is, since this function signature is exactly the same as this function signature, you can actually pass existing tests into a t.run. So I could pass something like test basic, for example, which is here. I could pass test basic in as the second parameter here, and it would run test basic as a subtest of test table driven. So that can be very useful as well as a way to kind of evolve your test suite into using subtests. So that's all for today. Just want to give a quick reminder to go check out minio.io, go check us out and follow us on Twitter, and go check out the blog. And of course, if you haven't already, please go subscribe to the Go in 5 Minutes newsletter at goin5minutes.com/subscribe. All right, everybody. Hope to see you next time. Take care.